We're jumping into section 6 on Venn diagrams and conditional probability. This is one of the more challenging sections out there. So we're going to have to look at all the different notation that we are going to deal with. So let's take this one step at a time and it won't be too bad. We're given this diagram where we have gamers and techie kids. So some of these people are being labeled as gamers, some are labeled as techie kids, some are both. So the overlapping area is ones who are both, and then we have people who are neither, who are listed out here on the outside. Now, the one thing to note is that the number of gamers is not 15. It is in fact 15 and 11 added together. So it is 26 gamers. In the same way, it is not 6 techie kids, it is 6 and 11 added together, or 17 techie kids. So those are the number 6 represents ones who are techie but not considered gamers. So number 1 down below, it says how many total people are represented in this diagram? You have the 15 gamer only, the 6 techie only, and the 11 both, and if you add those all together you get 21 plus 11, or 32. But you also have to include the people who are not in the circles. Just because they're not in the circles doesn't mean they're not there. So the 32 plus the 33 is going to be 65 total people represented in this diagram. What is the probability of selecting a gamer from the group? Use fractions. We just said it's not 15, but in fact 26 gamers that we have total. So the number of ways of succeeding of drawing a gamer would be 26. The total number of people we said was 65. So 26 out of 65 would be our fraction. The next part says, given that you have a techie kid, what is the probability of selecting a gamer? This is where things get challenging, is when you have this given or this condition. Given that you are a techie kid means that you have to come from within this bubble right here. So if you don't come from this bubble, it does not count. So all we are going to look at is that yellow bubble that I just highlighted, the techie kids bubble. It says, given that you have a techie kid, what is the probability of selecting a gamer? Well, the gamers in this situation is the 11 who fall into the one that is both. So there's 11 gamers in the techie kid group out of a total of 11 plus 6 is 17 people. So you have 11 gamers that are techie kids out of 17 total techie kids. We don't care about all the other numbers. We don't look at this, we don't look at this. All we look at is the highlighted area because it says we're talking about only techie kids. We're given techie kids. Number 4, given that you have a gamer, what is the probability of selecting a techie kid? Now we have a new situation. Now we have a gamer. And so the same logic applies as before, where you need to work from that to do that. So I'm going to let you do that one on your own. Down below, it says in a deck of cards. So this is not using the Venn diagram that we have. It says find P hearts / red. That doesn't mean anything to me yet. With this kind of notation, you're finding the probability of hearts given red. Or as we wrote it above, we would write given red, comma, probability of hearts. And that's how we're going to want to work out these problems. You start at the end. Given the red, then what is the probability of hearts? Looking at this chart, I have my 13 diamonds and 13 hearts, which makes up 26 red cards. 13 of those red cards are hearts. So going back to the situation, given red, which should be my denominator, how many hearts are there? Well, there's 13 of the 26 that are hearts. And if you look at the way this is written, it actually ends up making the fraction in the correct order. So for example, hearts, there were 13 hearts of the red, and then 26 total of the red. Now we have to be a little bit careful about how we do that, so let's do this next one together. Find the probability of red given Jack. So given Jack, find P of red, probability of red. So let's go back to that diagram. Given that you are dealing with a Jack, so you're dealing with one of these 4 cards, what is the probability that it is a red card? I don't ask you how many total red cards there are, because there's 26 of those. I only ask you, given that there's a Jack, there are 2 red cards out of 4 Jacks. So 2 red cards out of 4 Jacks. So for red, it is not 26. It is 2 red Jacks out of 4 total Jacks. That's why these are a little bit tricky. I'm going to leave the next 2 for you on your own. Just remember that it is the number of queen hearts out of the number of total hearts. Not the number of total queens out of total hearts. The number of queen hearts out of the number of total hearts. Same idea for the next one. The number of black aces out of the number of black cards in total. Good luck.